and I'll go ahead and let the team get started. Thanks.
All right, well, we can start with some introductions. I'm Landon Zentz, and I was the team lead this year.
I'm Braden Carter. I'm Eli Meekins. I was on the team last year, kind of helping them out and mentoring this year.
I'm Logan Mendenhall. I'm on the team this year.
Cameron Goodman. I'm also on the team this year.
Yeah.
That would be cool.
So this is everyone we've got today. We're missing Tim. I don't know where Tim's at. Parker is working, couldn't get the time off of work to be here today. And then we've got Alexis and Cameron Core that are currently loading up some additional black powder charges for testing. So, but that would be everyone on the team. So we can go ahead and just run down the rocket and show you what we've got, unless you've got some like specific questions you wanted to start with.
No, let's just run down the rocket from nose cone to tail cone.
Okay.
Or tail, not.
Yeah, we'll start with the trying to think how best to do this. Yeah, why don't zoom up into this? Okay. So, all right, so this is our 6-inch OD or ID Von Karman profile nose cone. It's a 5-to-1, right? 5-to-1, just off the shelf. This coupler is just a 9-inch coupler that came with it. And then if we look on the inside here, this is our bulkhead for the forward part of our drogue separation chamber. And we have 8 quarter-20 bolts around the perimeter here. This is a 1/2-inch thick 6061 aluminum plate on the inside with a 1/2-inch eye nut that is secured with, I believe, a flat washer and a lock washer, and then a just 1/2-inch bolt. But that's pretty much it on the nose cone.
Talk about for mounting. We're gonna mount the payload to this bulkhead using 2 1/2-inch nuts extending up into the nose cone. And then we'll use, not quite sure what the payload's gonna look like yet, but that is the current mounting hardware system that we plan to use.
So the payload goes above the bulkhead?
Yep.
Okay. Are there any electronics in the payload?
Yes. There.
Yeah, we're not 100% sure what all, they're still working out what everything. So for reference, we're working with our teams, or our school's CubeSat team. They're working on designing a functional payload for us this year. And they have been a little bit behind in some of the details. So they're still working out exactly what all is going to go into it. But there will be at least a GoPro camera. That's the main part of the functional payload. Additional electronics, they're still working out what's feasible, what's in the budget, that kind of thing. So.
And they're aware of the battery restrictions?
Yes. Yeah.
Okay. Good. Looks like the nose cone is that's a commercial nose cone, isn't it?
Yes.
So fiberglass?
Yep.
Okay. What's the shoulder length on the coupler?
So the coupler is 9 inches in total length, and so it's just 4.5 inches on either side.
Is the nose cone designed to come off?
Yes, the nose cone will separate off the rocket.
Ah, yeah, okay, yeah. All right. Shear pins on the side that comes off, correct?
Yes, I believe so.
What's being used to deploy the nose cone?
Black powder charges.
What type of shot cord is being attached to the eye bolt there on the
It-
bulkhead?
It is 2,800 pound braided Kevlar.
And that's being used for all the shot cords.
Yes.
Okay. What are you using for the main parachute?
The main parachute is, oh, I don't remember the name of it, but it's a 14-foot parachute, a 2.2 drag coefficient. I don't remember I can check the name really quick.
Based on that drag coefficient, it's probably an Iris Ultra.
It looks like it's a Rocket Man high
Ah,
performance. Yeah.
Yeah, Iris Ultras, I think, yeah, and Rocket Man's high performance, those are the high drag coefficient ones. So yeah, that's good. Let's see. What are you using for the drogue chute?
Same style, just in a 36-inch 3-foot configuration.
Mhm. Do you have those on hand?
Yes.
Yes, we can show you. They're currently packed up in their deployment bags right now,
Okay,
but we do have both of them.
that's good.
I can talk about that.
Yes, this is the drogue.
Mm-hmm.
Yep.
You don't need to, yeah, you wouldn't need to well, eh.
Yep.
Yeah.
Both of them are.
Besides, it's not good for parachutes to be stored packed anyway. How many shear pins are you using to connect the nose cone?
We're using 2.
Okay. Any particular reason why you selected 2 shear pins?
Based on the separation calculations that Cameron did.
Yeah, I think it was kind of done in parallel with all the other calculations for the charge required. I think it was just, I don't know if it was arbitrarily picked, but that was just the number that was kind of initially determined.
Has this been ground tested?
So the ground testing was scheduled for Tuesday. Unfortunately, the lab that we were going to load the charges in had some emergency, and we have not been able to get in and get access to our black powder to load and everything. So the 2 team members that are not here, Alexis and Cameron Ford, that's where they're at right now, is going and getting that set up.
Okay. Yeah, so you're using black powder for deployment. Let's see. What are the charge amounts?
For the drogue chamber, we're using 1 gram of black powder. That'll generate 11.4 psi within the chamber, exerting 322 pounds on the shear pins. The main is 1.5 grams black powder, exerting 9.34 psi on the chamber, 264 pounds of force.
Yeah, you'll definitely want to test those. Yes, and you are using deployment bags. All right. How are you attaching the shock cords to the eye bolts?
So I think just by a knot, just tying it through, it'll loop through eye bolts on both sides. Do you want to grab the halfway? So the shock cord will go through the separation bulkhead, the large one that we saw earlier, and it'll go through this one. Both are eye nuts. These are a 3/8 size eye nut, but
Does it go through both of them?
yes. I go through both of these and then through the big 1/2 inch one on the nose cone.
Okay. Did you use let's see, have you flown this type of attachment before?
That's what,
No, we have, some forms of attachments.
oh,
We had.
okay. So this is not exactly what they did last year, but you said you hide it, right? Yeah, so
So you're confident that these knots won't like come loose?
I think so. We'll take some measures to ensure that we won't lose the knots.
Okay. All right. So what are your vent holes like for both the electronics bay and for venting for the parachute compartment?
So we haven't drilled our vent holes yet. We were
Uh-huh.
waiting. That would be our final step. I believe it would just be one. I think it was, how big were we gonna order? 1/4 inch, I think, for the vent holes, 1/4 inch hole per compartment.
Yeah, so a small hole for the parachute so that those compartments don't overpressurize. And for the avionics bay?
Same thing, I believe. Yeah.
Okay. Yeah, just one hole may one other team mentioned that they're not doing a single vent hole because it can cause irregularities in airflow. What I would recommend is checking the your avionics manuals if you're for your COTS like altimeters because they will have recommendations for tube sizes
Okay.
in terms of holes. And speaking of your avionics, what are you using for altimeters and tracking?
So for altimeters, we have an Easy Mini and a Blue Raven. And
Alright.
then for our GPS, it is a Featherweight.
Right. What material are you using for your body tubes?
Body tubes are commercially bought fiberglass.
Okay. Do you have the body tubes present?
Yes. We'll start with the one most forward. This is the one that will connect to the nose cone. This one is same 6-inch ID diameter. This one's 38 inches long. And this is the section that houses the AV bay or the electronics bay. So
Oh, so the electronics bay is not in a coupler?
no, the electronics bay is in sort of this, it's here on the body tube.
Okay, and that's going, let's say I can see some holes. So it'd be bolted.
Yes, that'll be bolted in.
Okay. Interesting. That's not something you normally see. All right, can we take a look at the lower airframe?
Yes. So the lower section, very much the same, exactly the same
Mhm.
actually, just 48 inches long instead. This coupler is a full 12-inch coupler, 6 inches on either side.
Okay.
Same exact bulkhead as we saw in the nose cone on this side here, with the 1/2-inch plate and everything. And then at the bottom of this has the motor mount in here. And then this is where the fins will also be. So we have been waiting on parts and materials to get the motor mount done. It is finally done as of last night. But we've been waiting to get that done before epoxying the fins in place, seeing as how that's a permanent connection. We wanted to wait until towards the end to make sure that everything was going to fit together as it should.
All right. So one last part for this section. So I assume you're aware that you'll need to paint your team number
Yes.
on the outside of the rocket. Usually that's done on the fins on all four sides.
Mhm.
Let's see. Not yet. Okay. And do you plan on doing a test launch or?
We did plan on a test launch, but because of our big motor change and everything, that pushed us much too far back to schedule that in. So
What do your most recent simulations state your off the rail velocity is?
we are just over 100 feet per second. I think it's like 101 feet per second.
Okay. What are you using for your motor?
The motor is an Aerotech M2500T. Initially, we planned to use the M2000R. Of course, back in the middle of March, we found out that we weren't going to be able to get that motor. It just didn't get ordered on time.
Mm.
So we had to upsize slightly to the 2500. So
That probably helped to increase your off the rail velocity.
yes, that definitely boosted that.
Okay. Your couplers are using fiberglass as well?
Yep.
Just out of curiosity, is that from Rocketman or not Rocketman, Wildman?
Yes, I think so.
Okay, I think I've used Wildman's fiberglass before, so I recognize the pattern. They do good fiberglass. Okay. All things. Yep. Shoulder length. Yep. So shear pins and screws for attachments. What is going to be in the coupler?
I don't think we have anything but just parachutes and ejection charges.
I'd imagine if the electronics bay is in the upper airframe, the drogue chute is above the electronics bay.
Yes,
Okay. And the main parachute is below it.
yes.
Okay, so it would be a parachute.
Yeah.
Do you have any information on what the payload is going to be made out of?
I think they're still working on the structure of it. But all we know for certain is that it involves a GoPro camera.
Mhm.
That is the one component that has been verified. The CubeSat team that is designing the payload, they are very aware of the weight minimum, and so we will be hitting the weight minimum on the payload, but we don't have any details on the structure.
I think they were gonna try to measure GPS.
Oh,
Maybe one of them, like atmospheric sensors.
Okay. Since the payload is going to go above that bulkhead in the nose cone, I assume it's going to remain attached.
yes.
Okay. No. And yeah, and of course, the only thing you know for sure with electronics is that it'll have a camera in it. All right. So for the fin can, let's see, that's also fiberglass. What are the fins made out of?
Fins are a commercially bought carbon fiber.
What's the type of fin attachment?
There will be a small tab that protrudes below the surface of the body, but otherwise it will just be epoxy. We're using aero epoxy for the fins.
Okay. What is your current calculated fin flutter velocity?
I think the last time I haven't, yeah, it was, I believe it was 1,500. It was at least 1,500 feet per second.
And what's your maximum velocity?
Um, I think it was 900 actually, 900 feet per second.
Yeah, that does give you the required safety factor. What's the motor mount tube made out of?
So the motor mount is all made in-house, custom, if you will. So this is the hardware, of course, that we bought for the motor. This is the forward end. It is a 3/8 thick aluminum plate, secured with 4 rods that run all the way through the length of it. The rods are aluminum all thread that's 1/4 inch in diameter. The rear plate is 5/16 thick 6061 aluminum. And in between the centering rings are fixed length carbon fiber wallow rods.
Okay.
And those serve mainly to fix the longitudinal position of the centering rings, so they're the same distance apart from each other.
What's this black tube made out of?
This black
Yes.
tube, this is just the motor hardware
Ah,
that we.
It's the motor tube. Okay. Let's see. What are you using for motor attention?
So on the front end, the motor pushes up into this forward plate. And then this forward plate is bolted directly into the body tube. The rear plate is also bolted into the body too. So,
Okay, so you use the lowest centering ring as to hold the motor at that end.
not entirely sure what you mean.
So, like, could you slide the motor tube out of these centering rings from the back? The answer to
Yeah.
that is no. Okay. All right. What are you using for rail buttons?
So the rail buttons, we're still working on acquiring those. But it will just be a commercial off the shelf standard rail button.
What will be your method of attachment for the rail buttons?
Just screwed into the body tube. Or bolted, yeah.
Will they be bolted into something other than the airframe?
They can be. But right now they're not planned to be bolted into anything else.
Okay. Because that would increase the strength of their connection if they're screwed into something solid behind the airframe as opposed to just into the fiberglass.
Okay.
It gives it more grip and less likelihood of it just tearing out.
Right.
I'm assuming you are not using a boat tail.
No, since we had to upsize the motor, we had to cut the aerodynamic efficiency substantially, and so the boat tail was pretty much the first thing to go.
Yeah, I'm not entirely sure that boat tail would have survived intact at least. Okay, do I have any other questions? What batteries are you using for the avionics?
I think they're just D-cell batteries, standard Duracell. Yeah, non-rechargeable, I'm pretty sure.
Moment. Okay. Yep, those are perfectly fine. Have you done battery testing?
Yes, we've done a drain test on the batteries and the electronic components.
How long was the battery life?
So I'd have to check. Did not write that down. I'm sure it was in here. Maybe it wasn't. I bet it was in the report.
So I think Alexis said it was 3 days.
Yeah, for both of them.
Yeah.
So, I believe it was 3 days of continuous operation.
What were the conditions?
I think room temperature. Yeah, standard condition 70 degrees.
Yeah, so at launch conditions, that would be decreased, but I think anything over like 5 to 8 hours would be
Oh.
good enough.
Yeah.
Because outside of some weird circumstance, your rocket shouldn't be out on the pad for more than an hour or two, plus another hour or two for launch and recovery. Yeah, that's definitely long enough. Plus, it can be very hard to match launch conditions for an extended period of time. Okay. All right. All right, so that is everything for those questions. All right, so it looks like you still have a bit to go before being absolutely ready for the competition, but it looks like you have you're well on your way to completing the rocket. Do you have a rough timeline of when the rocket would be completed?
That's still a little up in.
That's something we're figuring out with having everyone. Yeah, it's for summer, so that's something that we're gonna be discussing here.
Okay.
Iron out the details.
So you still have over a month left. Um, so based on the task left, yeah, you still have a reasonably good chance of completing it. Completion. Let's see, the rocket was present. Yep. Mentors here, web record. These. All right. So a couple of things. How many on your team have attended a previous spaceport?
That's me.
Just one.
Oh, just you? Okay. Um, so just for the rest of you, there's a couple useful info things which is included in this checklist. So food and water is not easy to acquire at the launch itself. So make sure to bring food and water, particularly water. It does get quite hot out at the launch site. I think the highest temperature we experienced last year was around 105 degrees, and that's without cloud cover. You will need to transport yourselves and your rocket somehow to New Mexico. Since you're in the US, I assume you will be driving.
Yes.
Okay. We'll need to deal with shipping then. For everyone who hasn't been to Spaceport, there is a border check in between Las Cruces and the launch site. I believe, let's see, you may be stopped at least like cursory inspection. I believe they stop everyone at this point. But it shouldn't be a problem, particularly if you have anyone who isn't from the US on your team, make sure that they have ID. But otherwise, it shouldn't be too much of a problem. In terms of other material, the only thing you're required to bring now is chairs. We will be providing tables and pens.
Okay.
Which I really wish they did when I was participating in this event. We did not bring a table. That was fun. Let's see, yes, temperatures can get very hot. Black is not a good color to wear, so keep that in mind when choosing your clothing. Definitely bring hats, sunglasses. It will get bright, particularly when you're trying to watch your rocket in the air, as well as sunscreen. I typically will apply sunscreen once every 2 hours. That usually prevents the possibility of sunburn. Okay. We don't need to worry about visas unless you have anyone outside. Well, they'd already be here. Let's see. You have travel arrangements since you'll be driving. Do you already have a hotel selected?
I'm not sure what the accommodations are. That was maybe if Dr. Ash has information, he can share that.
Not yet. We're kind of waiting for the rocket to get finalized before we do that.
Okay, that makes sense. Okay. Let's see. Do you require any ham licenses for any of your stuff?
No, we
Okay.
should not require any licenses.
Yeah, since everything you're using is commercial. Everyone who's going on the launch to the launch pads themselves, they have TRA memberships.
Yes.
Okay, good. You do have a flyer record. Okay. So there's two final things here. Do not paint the rocket in hotels, dorms, or Airbnbs. They're very specific on that. And the final thing I have here is make sure to make smart choices. Be safe, have fun, and do not do anything stupid.
All right.
Now, do you have any questions for me?
I don't think so. No, I don't think we have any questions at this time.
All right. That's everything on here. So once this is finished, make sure to send a link to the recording of this review to general.info@ezrarocket.org.
Okay.
You just need to do that by the 19th. And just in case anything happens to your recording, I'll have one as well.
Okay.
So that's everything. I will let you get back to working on your rocket.
Okay. All right. Well, thank you very much.
You're very welcome.
Thanks.
Looking forward to seeing it fly.
Yes.
Bye.
Yes. All right.